visible.
Okay. So for the same operation, we will use another dataset from the statistics inbuilt dataset, which is called the cycling dataset. For the operation from file, open examples under the datasets. So here, if you look at the data, so we are giving you the basic data description. Here above, it is written 8V means 8 variable and 8C means 8 cases. So here in total, inside the data, we have 8 variables. Among 8 variables, first 7 are our factors and 8 column time is our dependent variable of interest. Let's have a quick walkthrough about the problem statement or the research goal. Here our research goal is, suppose a person here is asked to cycle up a hill on a consecutive days. The purpose of the study here is to determine the effect of all the first 7 different factors on the time with which the person can climb up the hill. From 1 to 7, these factor settings are for the seat, whether or not the seat position is up or down, whether the just a second, whether the dynamo is on or off, whether the handlebars is up or down, whether the gear is low or medium, whether or not the person is wearing a raincoat or not, whether or not the person had breakfast in the morning, and whether hard or soft tires are used on the bicycle. Here, if we click the view, then in the display options, if we click the text labels, we can very well see the 2 levels of each 7 factors. From the sheet, we can very well see that each has 2 levels, namely -1 and the +1. From the data, also from text levels, we can see for the seat position, we have only 2 levels. For seat down, we have -1 and one is seat up. So here -1 is the low level and the one is high level. And likewise, we have we have for each factors 2 levels. Next, we will come to the analysis part. How to analyze our desired goal. So for in statistics, from DOE means design of experiments. We have several experimental designs as Biswajit has already mentioned. So to the best interest of time, I am moving to the analysis. So we will choose the 2 KP standard designs. Next, OK. Now here we have 2 tabs, namely design experiment and the analyze design. So here we have total number of factors is 7. Let's write it 7. So from writing the 7 factors, and here we can choose the layout of our own interests. Next, if I click the analyze design, then if I choose the variables, in the dependent column, we will choose the time, and here in the independent, we will choose all the 7 factors. Next, OK. Then if I click OK, here in the design summary, we have got to see that standard design 2 to the power 7 minus 4. This means that you have 7 factors overall, 4 of which were created as aliases of interactions. This problem is a type of fractional factorial experiment. Here the fractional factorial design studies the only few main effects and some selected interactions. Here we use only a fraction of the full factorial experiments. So suppose here we have 7 factors, each at 2 levels. So we should have in total 2 to the power 7 means 128. 128 runs. So thereby, in order to reduce the experimental costs and time, here the design is taking only a fraction of the runs, that is 2 to the power 7 minus 4, means 2 to the power 3, means only 8 runs. So number of factors independent variable is 7, number of runs is 8, and total number of runs in the experiment is 8. Here 4 factors are aliased. Here aliased means 4 factors are mixed up with few interaction effects. Let us check once. Here in the design experiments, if we take the 7 factors, 1 block and the 8 runs, then click OK. And if we click the generators and aliases and click the generators of fractional design, it will give us in the left hand side the factors, and in the right hand side it is giving the alias. Here, let us take the first row, that is 4 and 1 2, which means the factor 4 here was created from the interaction of factor 1 and 2. I mean, in the analysis, you will not get to see the individual influence of the factor 4. From checking the interaction of factor 1 and 2, you will get to know the influence of factor 4. Likewise, the factor 5's influence also is mixed up within the factor 1 and factor 3. Likewise, for the factor 7 is also mixed up within factor 1, interaction effect of factor 1, 2 and 3. Next, in the analyze design, like before, if we take the dependent variable time and the independent factors of all the rest of the 7, then OK. Then here also we will get the same options, like in the quick section we will get the summary effect estimates, ANOVA table, Pareto chart to know which one is most significant and all. But for the best interest,
Pritha, sorry to interrupt. In the best interest of the time, you can get into the uh, the the workspace and you see how you can achieve the same through the R also.
okay sir. Okay. For the best interest of time, you can check the same operation from the prediction and profile as Biswajit has shown you from the PMML code. So for the best interest of time, I am moving to the statisticals visual workspace, and we will be using their R and Python. So workspace is basically used when the various persons are using various multiple tasks. Then after the tasks for the report for submission of the reporting documents, we can join the various workspace here, and we can do several operations in one go here. So if a person is conceptually clear, then he or she can do the same optimization problem using the R node and also the Python node. So first I have acquired the same data here in the workspace, Statistica's visual data science platform. Then I have taken uploaded two nodes of R and Python from Statistica's. Then inside the R node, I have written the commands for doing the same operation. I first assign the active statistical dataset to a working data frame called DF. Next, since all independent variables are categorical, so I converted them into factors to ensure the regression model treats them correctly as qualitative predictors. Next, I generate all possible combinations of the observed factor levels, which ensures that optimization is performed only within the experimental design range. Next, I have fitted the regression model, where time is our dependent variable of interests and seat dynamo to tires are our independent factors, as we have seen during our data description. Next, the summary of model will give the coefficient, uh, p-value, etc. all in one go. Next, I have used these commands for get all the categorical to get all the categorical combinations together. Next, in the step 4, it will predict the time with using the regression model and the new data which I have made in the previous steps. Next, our target time is 45. So as if you have seen inside the data, the minimum time was 50. If you note in your statistica, it will show you that your minimum time is 50. So now I want to achieve it as 45. Next, I have written this command that time minus target time. This is the this command has written in order to get the closer value to the 45, as close to 45 as possible. Next, the optimal setting to get the optimal factor settings for all the independent factors in order to get our desired predicted value as 45. So now if we run the node, so if we run the node, we will get in the below the optimal combination of all the categorical factors, that is seat down, dynamo low, handlebars down, here gear is low, raincoat is not, he or she is not wearing raincoat, breakfast is not taken, and tires nature is hard. If these optimal settings are used, then we will get the predicted time as 45. Similarly, we can do the same operation to achieve our desired goal 45, and in order to get the optimal settings of our independent predictors, we can get to the Python node also. Here the first command has been written for separating the warning messages and the outputs. Then I have imported the required libraries in order to run the operations. Next, I have assigned the active dataset from the statistical cycling dataset as DF. Next, since all the predictors are categorical in nature, so we converted all the predictors into categorical by this command to ensure whether all the predictors are categorical or not. Next, we have fitted a linear model with the same formula as time as our dependent variable of interest, and rest of the 7 are our independent variables of interests. Next, we will generate the valid categorical combinations in order to achieve our desired goal. Next, in the stage 4, we will predict the time. As we have said that our target time is 45. And next, we have written these optimal settings. This will give you the optimal factor settings for your each independent factors. So here, if we run the Python node by clicking the right triangular button, then we will get the output. The Python node is executing. So here in the below, if we look in the below section, we will get the same optimal settings for each independent factors for the predicted time 45. That sit down, dynamo is off, handlebars is also down, gear is low, raincoat is not given, breakfast is also not given, tires is hard, and then the predicted time will be 45. Similarly, we can do the same operation using the statistical desirability and profiling also. We can use the same operation using the statistical PMML code also. So the message is, if we are conceptually clear, we can do the same operation using different techniques and using the different platform. So that is from my side. Thank you. And I would like to request my colleague Praveen to take over the next session. Thank you.
Thank you, Preeta, for this nice presentation.
Thank you, sir.
Now I would welcome our Praveen, our data science statistical consultant, to deal with the same optimization problem or the response optimization problem uh, using the similar kind of the approach, but differently, like how to deal with using the popular Python code. I can also achieve my response optimization. Over to Praveen. Welcome, Praveen.
Okay, thank you, Vishwajit, and thank you, Preetha. So, my name is Praveen. I am working as a statistical consultant at Grid Analytics India Private Limited. So, let me share my screen first, and I will show you the same optimization problem through the design of design of experiments through the Statistica's workspace Python node browser. So I'm sharing my screen. So is my screen visible?
Yes,
Yes, Praveen.
yes, visible.
Yeah, visible.
Okay. So first, let me show you the data set. So this is my data set, which I have already uh, imported in the statistical workspace. So this data set contains 4 columns like time, degrees, yield, block, and 12 cases. So if we go and see from the data tab, we can see the text levels and all specification. Like here, the time is the given in minutes. Degrees is the temperature given in degree Celsius. Yield is the yield of process in grams, and block indicates the different shifts of the process. So why this data set qualify the design of experiment optimization? As we go and see, because design of experiment always deals with the factors and levels. So here we can see our composite data set has 2 factors, time and degrees, and these factors have 5 levels each. So to see the levels, we can go to the data type and text levels. We can see like we can see the level. Level is given here. Uh, we can see the 0, -1, 1, and these two is the another two level. Like we have the five levels for the temperature. In the similar way, we can see for the time. Time also has the 5 levels. So this data qualifies the design of experiment. So now I will give you this dataset description. So the dataset is based on a production process, which is taken from a production process, and we are collecting the yield on the basis of different times and temperature combination. So here we have recorded the historical yield, and we can see here that our maximum yield is, we can go to the yield column and statistics blocks under the blocks. Under the blocks column, here if we want to see the maximum yield which we have achieved in our production process, so that is 91.2, and which is coming under shift 1. So here is the maximum 91.2, which is we are achieving in shift 1. So my manager asked me that I wanted to achieve the yield like greater than 91.2. That is, we want our optimization of field, which we have already achieved in our historical yielding. So I will show you this using the Python node browser. So manager wanted to know, you have to achieve the maximum yield, whatever we have achieved in our historical process, and you can apply the any method, whatever you want. But only the thing is, yield should be maximized from the historical. So I will show you the same thing which we can use, which we can do through the using the statistical ribbon bar. So I have taken the Python node browser in the workspace. In the workspace, I have already written the Python code to the best interest of time. So here I am loading the important libraries which are needed for the optimization process. So import pandas as PD, numpy as NP, and the different other libraries like pipeline, polynomial features, linear regression. So pandas deals with the data frame or the tabular data handling, and the numpy deals with the mathematical operations. And this pipeline, which chaining the pre-processing and the modeling steps, ensuring transformations and model fitting occur in the correct order. And this linear regression, which I have used as which fits the coefficients to the polynomial expanded features, and then produces a smooth and differentiable response surface. So, and others like from site py.optimize, we have imported minimize and differential evolution. So here minimize used for the local optimization, which will use the LBFGSB method algorithms of optimization, which full form is limited memory Broden-Fletcher, Goldfarb, Sano, and in the bounded constraint. And differential evolution as will use as the global optimization. So now here I have loaded my dataset. This command df equal to active dataset composite. This will load the current active dataset in the workspace. And then df time equal to time dot as dot type. This uh, will take time and the temperature as a continuous input. And this command blocks as dot type category. It will consider the block variable as a categorical input. So here I am defining my target yield as 95, and I have taken a hypothetical value of target yield 95, and I will um, optimize the process uh, to the nearest, which is nearest to the 95. Then I go to a loop over the categorical block. So for block in df block dot categories, it will take the it iterates over each distinct block level, which this avoids treating block as numeric and producing meaningless fractional block values. And then this creates the subset of data for one block and label copy. This label copy prevents change assignment side effects. Then we define our predictors. Here we are defining our predictors, block, time, degrees, and yield as our response variable. Then here in the step 2, we can see local refinement LBFGSB, which I have as I have said, this LBFGS is the algorithm method which is used for the optimization here. Limited memory, Broden-Fletcher, Goldfarb, Sano, and B for bounded constraint. So here results equal to local minimize objective. This means it will starts at a global search. And experimentally observed region where we prevents invalid extrapolation. Then after doing this local optimization, we are getting here I have written if best solution is known or ABS of optimum yield and target yield, which will throw the best optimum value of the yield. Then I go to the final result, which will take together global plus local optimization result and will take the optimum among both local and the global optimization process. And then we print that optimum value. So when I run this node using this green play button, we can see here below the running status bar in the green color. Now we can see our through the top right corner, we can view the report documents. So it has generated two outputs spreadsheet, first output and second errors. So in the output spreadsheet, we have seen we can see clearly this block 1. When the block value 1, this means in the shift 1, when the time is 83.97 and the temperature value is 1 150 degrees Celsius, then we can achieve our yield value 92.107. So this is our optimum settings through which we can achieve our maximum optimum yield, that is 92.107. So we have the potential in our data set to achieve more than what we have already achieved in our record. In our record, we had 91.2, the maximum, but through the uh, through the different algorithms of optimization, we can achieve the maximum than the historical value. So here is the maximum 92.107. So this is how we can achieve the maximum through Python workspace node browser. So thank you. This was from my side.
Thank you, Praveen, for this nice presentation for the section of collective intelligence. So we
Yes.
approach to solve our field maximization using Statistica, a visual data science, no-code, low-code tool. Then also we approach through the R because Statistica is a commercial software. You need to pay a license fee uh, for it's a commercial software, so you need to pay a license fee to use the software, right? If we understand the concepts, let me share my screen to summarize our agenda, or did we cover everything what we had described in the agenda? So let me summarize the agenda: introduction to optimization. Now we have the necessary understanding what is optimization is all about, how we can achieve uh, our maximum potential, which is hidden within the dataset. Introduction to design of experiment, right? So design of experiment is old approach for the purpose of optimization. Problem solving using Statistica, how we could approach and solve one of the optimization issue, the brightness from uh, what we had achieved so far, it was 45. So we could, sorry, the brightness was 40. So we could achieve the 45, that is the maximum. So there is a 10% increase in our yield. When problem solving with collective intelligence, the same optimization we could approach using the popular open source software like R as well as Python. Raw data to model deployment. From the raw data, how if we can deploy a model for the new data set for the purpose of prediction or for the purpose of the scoring, right? Now I would invite all the participants. If you have any questions, please feel free to ask. If you have any questions,
Yes, I have this question. So this is Aarti Shukla from CSIR CMAC. So my question is, we apply design of experiment in machine like HPLC, NMR, and LCMS, and we found large data according to area and content. So I was confused ki what to apply area and percentage content for this DOI and machine learning data.
no, Ramesh. See, the Statistica, in fact, most of the software they support the multiple source of data. Multiple source of data means multiple format. It could be the
Yeah.
links, laboratory equipment, manufacturing, like NMR data. So that generated by machine. So largely the machine generated data comes in the CSV form or text form, right? So for the Statistica, it's not a big deal. Your data could Statistica support 165 formats.
No,
right?
this question is my data is according to area, and we do percentage content for using this formula. And what I selected area and percentage content of this data.
If your data is in numbers and your output is in numbers, right? The data could
Right.
be thousand, the data could be lakh, the data could be millions. It does not make any difference. But there are certain fundamentals. If your input as well as your output is in numbers, numbers means it is continuous in nature,
Yeah.
right? So then
Yeah.
you can apply the way we apply the multiple regression. You can apply the multiple regression for the purpose of prediction. If your data consists of the different levels, like the factors, you have the factors time, right? So you have it 120 degree, 130 degree, 145 degree. So this is the way you have collected the data, right? If you have collected the data in numbers, then you can apply multiple regression. If your data are in levels, various levels, low, high, medium, you can approach to the design of experiment.
Okay.
Right?
Thank you, sir.
We deal with the three type of the data. One was the textile data. The data was a mix of categorical as well as continuous, and my output or my response variable was a brightness, which was continuous in nature. Right? So we could apply the desirability profile. We can apply the multiple regression, and we can do the optimization also. So depending on the nature and the structure of the data, you need to take a call. But the algorithm will remain same, right? So widely for optimization, DOE, they use in the background the simplex algorithm. But here you also learn one of the modern age algorithm like LBFGS, right? Yeah. So I hope this answer your questions. As anyway, Praveen is supporting through offline also, Aarti. So
Okay,
you
sir.
can reach out to Praveen. Fine.
Okay, sir.
Yeah.
Thank you, sir.
Yeah, Mr. Prasanjit, please.
Sir, thank you for organizing this webinar. Sir, I have one question, small question that how to get this software. Actually, is it a free software or I have to purchase?
No, I said it is a commercial software. So you are from an organization, institution, or like
Organizations. Hmm.
which organization you are from?
ICR organizations. Indian Council of Agriculture Research.
No, I know more than 20 ICR organization across India. They have been using Statistica, and
Okay.
your benchmark also ISRI, right?
Hmm.
They have been using Statistica since a long time,
Yeah, yeah.
right? So you can purchase the software, but suppose you do have any kind of the research project, you need to perform analysis ad hoc wise, we can support you. We can give you a free trial or something like this. But alternatively, because this is like most of the research intensive organization, they purchase the commercial software. They have the budget for this. If not, we are willing to support you.
Sir, is it perpetual in nature, the software?
Yeah, we have a flexible licensing policy. We do have the perpetual subscription depending on the budget.
Okay, okay.
We can give you many of the reference of the ICAR institution who have been using the software, right? So we can make your, in case you decide to buy Statistica, we can make your buying process much smoother. We have many reference from ICAR institution who are already using the Statistica.
Okay, sir. Okay.
Yeah, please, Mr. Bisal, I would invite you for if you have any questions. Mr. Bisal?
Yeah, sir, I have a question for Praveen.
Okay.
Yeah, please
Praveen,
go ahead.
Yeah.
could you
Yes, please.
your data set this was defined for a design of experiment problem means the time factor.
Sorry, your voice is breaking up in
in your data set, the time factor is available, right?
Yeah.
So how the time factor you explained, how this time factor is related to the design of experiment problem?
See, in my data set, there were two factors, right? Time and temperature.
Yeah.
And both time and temperature has 5 levels. So in our design of experiment deals with factors and the levels always. So we can consider time and temperature has 5 levels. So this data set qualify the central composite design.
Yeah, does it answer your queries?
Yes, sir. Thank you.
Any more queries is there?
Thank you.
Any other queries is there? Okay, thank you very much, each of you, for being with us. We are signing off for now. We will upload this, the recording, although I did a slight mistake. I did the recording, I forgot to record it. I did the recording a little later. But anyway, we will share you the session recording to all of the participants. Thank you very much for being with us. Bye-bye, take care. Have a nice weekend.
Thank you.
Thank you, sir. Thank you.
Thank you all.